And we're back, folks. I'm going to say this right off the bat. This is going to be a long one. But man, have I got some good stuff for you. And here, let's start with this real quick. I turned up the volume because I wasn't happy with it. So I'm hoping it's not terrible. I really won't know. 2 hours. Who knows? All right, look. Wait. Switch to... Okay. I don't know if you can read this very well. I'll just read it to you. Excuse me. Tom Ryan said, "Wishing you all the best, man. It's a long journey. I appreciate the effort you're putting in." Well, I appreciate you, Tom. It is a long journey. You're not wrong. But there's a way, Tom, that we can speed this up. And I'm going to show you. Because we talked about functions and we talked about, well, we didn't get to OOP, but we're going to get to that. And we talked about an entry point library and I've rebuilt an entry point to make this easier. We're going to jump right in and you will have your own entry point libraries very quickly. There's this whole talk.
An improvement over using preprocessor macros, and the biggest benefit is that it is a language feature, right? Aside from preprocessor macros, it is the second thing that is the easiest
sped up at the moment,
consistent throughout the program's lifetime, or is already known by the compiler beforehand, and then this basically allows the compiler to actually compile them. But inside of config.json, I have an API key.
This is from 6 months ago. So, I just watched it. So I just stumbled on it, really. Man, is there a way I can get it bigger? But you'll notice he's using these, what are known as preprocessor macros. It's the pound symbol there. With if, elif, and endif. And that's pretty much the same thing as our if statements, except that they're preprocessor macros. It's kind of like the include preprocessor macro. And what we use that for is, you can see right here, we would want to have different implementations. And that's what he's talking about. You gotta keep those to a minimum, is what he should have said. He says you don't want to use them like this. Well, that's true. You want to avoid this kind of stuff. And in the implementation I'm about to show you, it doesn't actually have those much. It's much cleaner, much more readable than this. And I think that was his general... Anyway, it seems to follow most of the principles that he's discussing. So I definitely wanted to share it. We're going to get into it. But it's going to be a little bit of a slower stream. It's going to take a while. So... What did you say? What did you say? I got bit by a zombie? No, if you want to know the honest truth, I'll tell you. I'm a high functioning autistic. I have a very high IQ, but I have a lot of quirks because I'm autistic. And one of those quirks is insomnia. But I honestly, to be honest with you, this is mostly just from being on the computer way too much. Obviously, I'm a coder. So.
Thank you so much for calling.
So we finally used the static library. Getting that set up. In Visual Studio, you got this right here. Active debug release, all configurations. When you go to compile it, let's say go and release this thing. Run. Well, this one handles it differently. It's not supposed to have the console. Yeah, right there. That's what's making it. This should actually be. I don't know why that did that. I guess because I chose the console application template. You could do an empty one and it wouldn't. Probably just leave it blank or something. Yeah, I guess the Windows desktop example would have been what I was starting with. No, it's still doing it. That's weird. That's really weird, actually. It's just because it's an int main and not a win main. But anyway, this actually pulls for input events, and which Owen doesn't yet. It's got full implementations, mostly, until you get down here. That's pretty empty. Just the Xbox and PS5, I guess, but this is the kind of set you really need to support. This is what cross window supports. It's basically just one. You have entry point cross platform, and then you have the CPP for it, which is all of the if defs that I was talking about. Actually, if you highlight one, there you go. And it's just selecting the operating system based on the. It's really not a proper way to do it. You should create your own binds that could be based on these, but it should also have some kind of a. I guess the idea is that these right here, these predefined macros, they are defined on these systems. However, what if you're not on any of these systems? Then what does it do? It doesn't even have a case to handle that. For one, it does here, but the point is that what he was discussing in that video was trying to make this easier. And if you notice, this is a header-only design for the most part. I don't know why the Android and Scriptum have to be CPP files, but they are. It's just like the iOS and Mac are .mm files. But the thing works. It's basically of my own design because, well, it's very similar to other designs. It's more C++ 20 than 17, I guess you could say, than most of the libs you'll find out there, like Xwindow or Crosswindow. But this is basically what I've trained GPT to do over the summer, and it's prompted by my own personal prompts in it. I'll probably release this one as a separate. I might even revive the Crossview name as opposed to Almond Core. Almond Core is more of a game engine. It has all the makings of a game engine. And I don't know that you'd use everything that it has in just any software. I'm a little biased in the way that I view this because I only work with games. So I don't really know how other software uses programming, really. I know that they all could use cross-platform frameworks, so that's why I want to release this as maybe something a little more fundamental. But this is the way it works. It's pretty straightforward, and it's really easy to understand. As for OOP, well, we learned how we include other files, and you can see I have other files. And the way that the static lib versus the executable console application work is you go into the properties, under the CPP, you're going to add the inclusion files from that lib. This could just be the entire source. In smaller code like this one, it's just the entire source. But later on, you might want to suss out what are the include files, the only files that your exterior source would ever call to. Probably interface files if you want to do a facade design, which I'll probably end up showing at some point because I still use it. It's highly effective. Another option is templated functional programming, which I'm still kind of learning myself. So what I've done here, it's a little easier to see here. I use the solution directory. This makes it a relative directory. And of course, solution directory is wherever your solution is. And then there's always, the way that we're doing it, there's always a file with the project name. And then you have, well, this isn't the actual one. This is. So you have static lib and you have console application, and that's where all their source lives for now. So this gets you directly to the static lib source. So it's the include files for it. It could be this, or it could even be in some libraries they have you include this part, and then they just include their files after it, like in here. Then in the linker, what you have to do is in the general linker, you can think of this as like, I think of this as like CPP files, this is like header file. But if you go to general, you'll get additional library directories. And you definitely want to link library dependencies if you're using this. This is where you're going to include where the .lib actually lives. So the compiled library is where this is. Now, in my projects, again, I use relative directories. So it's going from the solution directory, and then there's always a bin. I create the bin. I put this code in here. So that the normal one is like solution platform configuration, but it won't be in here. It's in up in here. We'll look at that in a minute. The solution directory, I create a bin, and then the bin has the exit. Instead of this file, we don't need that anymore. I eliminate that. And I create this instead, and then those live in there. So then you get x64 or x32, whether it's 64 or 32-bit. You might even, if you were to take all these files cross-platform, I don't know why you would do that, but if you did, you'd end up with more folders. But anyway, then you get the different versions, debug or release, then there's your files. Here's the lib, here's the executable. These are additional files that are part of they're the debug files, the program debug database. So these are only used when you're using Visual Studio and you've just built it. When you redistribute, you don't need that. You only need these. Any DLLs, any .libs that are involved that aren't statically compiled in. In our case, it's a static lib. So we don't even need that. It's already contained in here. So we could take this, move it anywhere we want, and it's a standalone program. You see? It doesn't need those files anymore. That's what a static lib does. Now, what's the difference? What is that? I've never heard of a .lib. Well, you've never heard of it because it's compiled into the executable. The other way to do it is to make a DLL, a dynamic link library, which can be shared amongst programs. So you might have one DLL and a bunch of different executables. Like in game design, it's not used as much as it is used in other things, but you might want to compile your engine as a DLL as opposed to a lib, because you might use an editor that calls into your rendering library to use it for its own rendering, and display your engine in the way that it works. So that's the difference between dynamic link libraries and .libs. Libs don't require any real code to make them work either. There's one more part of this I gotta show you, and that's additional dependencies. You have to actually name the file that it's going to load, file or files, whether it's .lib or .dll, that it looks for in the additional library directories. Now this might seem confusing, but honestly, these are some of the only functions you'll ever use in these options until you get involved in optimizing the build and things like that. Adding a version to it if you ever use this function. A lot of people use their own implementation for versions and stuff, so they don't even use that. Cross-platform wise speaking, you want to use your own implementations for pretty much everything because you never know what that system defines. You could be coding for Linux, but you could also be coding for a Linux kernel. If you use the VMware like I showed you, you'll notice that it has different kernels for different types of Linux. Like you might use the Red Hat kernel for 5 different types, and then you use the Ubuntu kernel for 12 other different types. So you could be on a system some random person on YouTube just invented, and they may not even have integers set up correctly, but they might have a size t, who knows? So you define your types, and you say this type equals this size, and if it doesn't, well then you got a problem, cause an error, and that's called soft crashing, where you get an error and it closes properly and shuts down the code properly, as opposed to a hard crash where it's spilling stuff into your memory and just leaving it there. Why is that bad? Well, if you do that enough times without rebooting and refreshing it, or if it damages it and gets stuck there, or just damages it, the RAM, I'm saying. So that's how you include a static library. There's one other section in here you'll use quite often and right away. And that's where you define what version of the C and C++ languages you're going to compile with. You also need to add the bin part right here. You need to add project name right here, because that's the intermediate directory. That's where all that junk is. And if you don't want it all laying on top of your executable, and you want it in a nice file named after the project next to the executable, then you want that. This is where you decide whether this is an executable or something else. So you could easily change a .lib to a .dll, for example. Or you could make this run with a makefile. You can choose your Windows SDK version, the minimum you can compile this and run this on. Windows 10. Platform tool set. That's the version of VS you're going to use. Most of that stuff you don't mess with, but this, and this, I have to change every time. You can set up templates that do this all the time, and the key thing when you're setting up any of that is that you're on the correct configuration. Otherwise, you'll have to do it again, and again, and again, and again. Make sure you're on all configurations when you set up these, and then when you set up these, you can actually copy this one and place it here, or here. That'll go directly to the static lib from the other one, because you're going to set up the static lib just like that. So that's where it'll dump out. Then you'll read it from there, or you can put it in a lib file, or you can put it wherever you want once you learn how this works. The OOP. OOP is basically when you create a class and you start making those classes do anything that isn't static. In other words, they're interacting with another class. And you almost always put each class in its own set of files, which will be .cpp and .h. If you've taken any other tutorials or tried to do this at all without my help, then you've learned that there's two different files, and that one contains, in C++, one usually contains a definition, almost like a forward declaration. And then in the CPP files, you have your implementations. And it could do things that aren't inside of the declaration. But we'll almost always have at least one command like that one. And that's just a static list of unique pointers. So every time you create one, it just adds one to the list. And this could actually be used quite easily in the form it's in, because the way that I wrote it when I was dealing with GPT, the way that I wrote it was I wanted split screen. So this should be very easy to do that with. One thing that I took out of Almond Core when I was rebuilding it again was where is it? Let me think about this for a second. I think it might be taken out of this again as well. I think what I took out was like a class Almond Core. No, I did make a class. I had to. That is part of it. But you can see how basic this is. There's nothing here. It's just a header implementation, which of course needs extended, but you do it inversely. Like this could have, this would basically include, even though, what has it got in here? Yeah, it's got Android files, but you would include your files. So you'd have like, we'll call it your Android implementation. And just as an example. So you could start including your source, and then in show, you would use your implementation to something like this. Something. You know, create a what is it? Android. So create a I don't know. We'll just say create pen. Something to give you an idea. And then you might show the create pen implementation or something. With SDL3, there's a pen implementation, so that kind of makes sense. Let's see here. We gotta undo these. So, like I said, it's super basic. There you go, right there. It just takes a width, a height, and a title. And that's practically all you need or want for cross-platform window or entry point. See, normally you would call this file window.h, but I don't like that term. It's too... It's like too ambiguous. It's like there's too many things you want to call a window. Like, for example, if I was to implement my own UI, I would have a window, and that would be called window.h or window GUI.h or something. So it becomes confusing in the code. It's not recommended. I went with entry point. There was another entry point.h at some point. It got renamed to this. You could just as well do that and just rename all of it, because it really doesn't need to do that, but it is more descriptive. So do you leave it? Do you? I think that as an example, it's good to have it, but if you were to download this source, you would want to change it and use entry point yourself, or your lib entry point, something like that, to be descriptive. And the reason why you do that is when you make class names, we learned about namespaces and how it can protect your code from this, but you still want to have very unique names so that if your code is ever leaked out of that namespace, like for example, somehow they use your namespace and you're both within the same namespace. This is probably problems that were more prevalent with C code and things like that, and that's why namespaces were created, but you'd want to have something unique just because that's more descriptive itself. My entry point may be similar to your entry point, but it's not necessarily the same implementation. And it could be done completely different. And if you were to use both libraries, you would be very confused. And not only that, it would call both at the same time. So there's another reason. Like I said, sometimes you invade namespaces. Okay, more often than you think. But this basically is nothing more than if-def macros with the basic C++ defined platforms, no real good error correction except for this static assert, which is probably not that great. Yeah, I mean, it doesn't get any simpler. It's clean, it's header only, and this even has, like I said, the polling for right here for events. And my engine is event-based. You could poll for input, but you could just consider that an event. In my engine, it is. So a lot of engines, a lot of modern engines, that's probably the case. So this is as deep of an implementation. If you're going to make an entry point lib for any use, this is as deep as you ever want to go. That is enough for a game engine in a lot of cases. In modern cases, you might want to go deeper, but someone could easily add a few functions and change this. And it's so simple and pure. The other thing I wanted to show you was what helped me do all of this. I call it text file combiner. It's actually like a code file combiner. And it just takes, this is available on the GitHub already, has been for a while. It just takes, it looks for CPP files in a folder, added a file manager that can, it's just an open file dialog. I think that's also available. It's available with this source. Same exact source. I haven't touched it since. If extension CPP or .h, I need to add a few more in here. I've learned that it also needs RC for Apple files and Windows resource files for Windows Desktop. So that'll probably be an update on that code. I hope this works. I'll have to play with this later, but it only works on Windows. I can tell you that, first of all, because of this. That's something I should write, is a cross-platform version. But I just got the VM working for Linux. I was going to go through all that with everybody. Yeah, I didn't select a folder. It's got some decent error handling. GPT basically wrote it, and what it's for is it will take all, it'll fire up and it'll say, give me a folder. And you'll go and give it, well, we'll just do this one. We'll do the backup. And then it'll ask for another output folder for this file. You can rename it. I think it'll probably just save as that anyway. Let's try. We'll call it TTTTTTTT. File combined successfully. Okay, so then, because GPT has quite a large limit, you can compile all your source. If it's under 25,000 characters or so, it'll accept it all. And then it can read all your source at once. That was a big hurdle to... Oh, it does work. Yeah, that's cool. So then you can see all the source of my backup source, which is only like 6 files of some old source. But it's all there in one file, all these files right here. And then you just feed that into GPT, and next thing you know, it rewrites your whole lib for you. And if you have all the proper prompting, like I explained before, it'll spit out the code you want within reason. It's also getting GPT 3 and 4 are renowned for deceiving the user. GPT, the newest one, does it too, but they have built into the model not to do that. And the reason why it does that is because it's trying to save resource. And you might say, well, that's dumb, until you find out that GPT runs in this giant facility, and we're all hitting the heck out of these GPT servers, and that costs money, it costs power, and it pollutes the planet. I mean, we're saving money by using GPT because we're saving time sitting at our computers. We're being more productive, and that is the best efficiency of it. So it actually helps the world. But when you compact it into one building the way that it is, it's like the Microsoft server that are in the ocean. It's warming the oceans. So they're having to move. Now they're talking about putting them in space or something. I don't know, or on Mars or something. But Anyway, wouldn't that be cool if we could GPT and game our way to terraforming? To just take all our servers and put it on a new planet and feed it all back in Wi-Fi. The future is going to be nuts. The future is going to be nuts. And it's going to be even better if we all learn C++ and learn how to manipulate this tool. And we can all make our own games and things like this, and it'll be better for all of us. We can terraform planets with games. But that CPP text combiner, I guess I didn't really explain object-oriented code all that well, but I do actually have, let's see here. Oh, there is another thing I wanted to show you. Check this out. This is an online, you can test code online, but not only that, it shows you the assembly code. So if you think you got, it's at godbolt.org. It's called Compiler Explorer. This thing is so cool. This is what I've been looking for a long time.
Hello and welcome to
Jason Turner. Okay? Jason Turner. He's done a lot of talks at the CPP conference, whatever. He does CPP weekly. Definitely one you want to subscribe to. So what we got here is, it's running the code and we can see the output. Also, there's a way you get the output to come up. It's down here. You gotta get it to compile, and then you can hit output or something like that. I can't remember exactly how I did it, but you can get a diff view, a tree view, IDE mode. You can I don't think it gives you the intel. It might have some IntelliSense, not Microsoft, but okay. It has syntax highlighting. Oh, there it goes. See that? And now it compiles and just runs it automatically. So you can, now this is taking their time, but if you want to use this so that you can see the assembly, you can figure out if your functional programming or whatnot is, like, what does it do? Like, what does it do when I include Windows? How much overhead is there to that? How does it change the code? It looks identical to the code that was there before. Let's see what happens. There's the main. That's not it. Yeah, it looks identical. So, I mean, there you go. I mean, that's pretty much the answer. I wouldn't rely on this for that, but it can give you a definite insight into what different things do. Like what happens. Maybe you've looked at strings trying to cheat at video games or something, and you're wondering, like, how is it that a string, you know what I mean? Compilation failed. Because it's a declaration inside of, like, the active scope, as opposed to, like, a global variable, probably. Oh, and I didn't include IOStream. That's... In fact, we don't have to include all of IOStream for this, because it's just string. We can just include string. We'll probably even get away with C string. Okay, maybe not C string. There you go. Now you know why strings are heavy. What is all this? Bad allocations? Base array? So by not doing anything with it, we've caused a bunch of bad allocations and it has to correct. Is what it looks like. Yeah, bad allocation, exceptions. There's all kinds of exceptions thrown because you created a string and did nothing with it. Now we do need IOStream because we're using cout. Now we got options here. We can do std and line, which is really easy to remember, to be honest. Or you can do the newer version, which would look like that. Now why did, oh, it is compiling. So now we've used it, we've printed it. Look at all those errors. What's up with that? Now that could be due to this thing being like a virtual machine. But you see it's got actual implementation at the bottom here. And it's just a bunch of like image, relative, integer, basic string. Weird. RTTI. Hierarchy descriptor. This is interesting. And some of the, right now I'm using, you can change different compilers with it. Right now I'm using Windows. I don't know. So strange. Errors. I don't know why. Maybe it's the square. Failure. RTTI class. What is this? Runtime type information. Now, why would it do that? Allows it to be determined during program execution. Well, it could just be like this editor's association with standard template library because that's not really the way it works. It's supposed to be integrated into an environment with the code. Let's try something else. Let's try something like simple that doesn't include IOStream for one. Let's just try the anime and see what that. Wow. That's really interesting. Oh, okay, here we go. It's a XOR operation, XOR. So main process. So what's this? Scope? Is that scope? Looks like scope to me. Looks like an automatic return function they put in there. Remember we were talking about that? The XOR is probably, I mean, just looking at it, I would guess it's the command line arguments, but I'm not so sure about that. Well, let's try something. Let's do, let's just do, ooh, this ought to be interesting too, because it's doing something weird with true. And just do nothing inside of a while loop. That's the problem. problem? Killed, processing time exceeded. Oh, okay. Yeah, so there are limitations to this, but it can really help to diagnose code for sure. Especially if you want to like flip through the compilers and get stuff done. Oh man, it was just showing it to us too. If we put a, let's see, probably do a system pause. Oh wait, that's not gonna work. Let's try that. Oh, we had something there. Failed. Identifier not found. Huh. Well, how about... Here's that one case we were looking for. Do while do while false. Does that work? I don't know. Let's try it. It works. It works. That's good to know. See, it's already teaching us stuff. And it's the response time, the workflow time on this. Well, that's interesting. So this is all part of the loop or whatever. Because this is all we had before was this, 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 and this. So all of this, actually, this much of it is the loop. Look at that. When I hover on it, you can see what it is. Perfect. So a do is an end pad, whatever that is. Null padding. It's not null padding, but it's an end pad. That's the false. This is the while. So what's the extra XOR? Where's that extra XOR we had? What if we select all this? Does it show? It's not even like doing it anymore. But anyway, super awesome tool, right? Thanks for that, guys. Whoever runs that thing. Definitely star that one. What else was I going to show you here? We showed you that. We want to talk about OOP. Okay. Let's see here. I got some examples. Oh man, it's not like in this one. I don't know what. You know what? It's okay. Let's just start a new one. I know this is cheap, right? I'm cheating. OOP, C++ 20. But the fundamental example this thing can spit out, this isn't cheating anymore. This is how you do it now. That's what you need to understand. Just like we have electronic symphonies, we have DJs for musicians. And by the way, I don't know if you realized it, but like the one-man band or the classic musician band is pretty much practically already extinct. DJs are the closest thing you got to folk music in 2024. Okay, so this is like trying to draw a circle in a square. It's using some functions. We know functions. We get that. So we got templated functions. We don't get that yet, but we'll get there. And so it's classes. Well, these aren't functions. What's going on here, right? So it's using a function and it's passing it a class, right? We could see that. So what's going on here? Circle. Draw. Okay. So classes have functions. And this function is called draw, which really, it's just drawing text to the screen. But it could be doing something else. It could be using an image mask to make a circle, etc., etc., etc. This is legit. It's the beginning. This could even be considered like it's error code, or it's really debug code, so you can see that it performed its duty. And so it's good to use, and that's why you use cout just endlessly when programming. And by the time you're done with your program, it probably will remove all these. Maybe. It just depends on your coding style, really. So, drawable. Okay, so drawable. What it's doing is it's just making a template class. It doesn't really matter what you call it. But other than the fact that it needs to be descriptive. So you need to understand what your template name is. Like, we want a drawable class, right? We want to render it. So it's drawable. It's a drawable T, which is template. This is right here. What you're doing, what you're really doing. See, everything you do in C++ seems like you're doing one thing, but you're really just using other smaller parts of C++. This is just the same thing as this. It's identical. But you use T over and over and over as a standard. Why? Because it's descriptive. So it's readable. When you read this code, you can read it. You go, oh, that's a template. I noticed because of the T. Or if I write something there, why did I write something other than T there? And what did I write? Is it descriptive? This has a render, which is not a draw. So we know that it's not inheriting that. But what is it doing? It's using this constant T, this constant object, or rather it's making it a constant object, and it's using a reference. So what does this do? This is the same thing as this. So you're getting a reference to this. So when you create a drawable, or you use this exported function, it's going to create this whole thing as a constant T reference, which doesn't really exist. It's just a reference to it. It's going to name a shape, and it's going to use shape to run the draw call. So how did those connect? How did you get shape to here? Well, that's right here. That's right there. You call render. You already created the circle. Okay, you got a. It's not a reference or a pointer. That's a C. That is a class. That's a class definition or declaration. Implementation even, or forward. It's a declaration. It's just like a forward declaration, except that it's not forward. It's immediate. So we immediately declare circle as C. Then we run this function that we call basically from thin air. So when you call that function, the compiler's like, okay, you got render function. Okay, so what is that? And it looks for it. And it goes, oh, I got this templated function. Is that what you mean? Of course it is, because it's the only one. So then it makes a constant template of it, makes a reference called shape, uses shape to run a draw call on whatever you pass to it, because that is T. Now we know templates and OOP. It's probably a good time to end this one for now, but I'll probably be back later. This took a little while to figure out and set up, so when I get it figured out and set up, that's when I'll do another one probably. Happy coding.